Welcome back to Computer Lessons.
We have spent the last few weeks assembling a technological marvel. We have the silicon brain that calculates existence, the memory that holds the fleeting present, the storage that archives the past, and the artist that paints our digital reality. But look at the machine sitting on the desk. Without the final component we are discussing today, it is nothing more than a collection of expensive sand, metal, and plastic. It is a dormant statue, cold and lifeless. Today, we are talking about the power supply unit, or the PSU. If the CPU is the brain, the PSU is undoubtedly the heart. It pumps the lifeblood, electricity, through the veins of copper, waking the machine from its slumber. Yet, this is the most disrespected component in the entire industry. New builders will spend thousands of dollars on a graphics card, but then buy the cheapest, lightest power supply they can find to save $20. This is a catastrophic mistake. A bad RAM stick will just crash your game. A bad hard drive might lose your data. But a bad power supply? It is the only component in your system that can physically kill every other part, start a fire, and burn your house down. To understand why, we need to look at the physics of the electricity coming out of your wall. The power grid delivers AC, or alternating current. Imagine a wave in the ocean, rising and crashing, going positive and negative 60 times every second. This high-voltage oscillating energy is fantastic for light bulbs and toaster ovens, but it is poison for delicate silicon chips. Your CPU and GPU need DC, or direct current. They need a perfectly flat, stable line of low-voltage electricity, not a crashing wave. The primary job of the PSU is to act as a refinery. It takes that dangerous, high-voltage, chaotic AC power from the wall and converts it into a clean, stable, low-voltage DC stream. It steps 120 or 240 volts down to just 12, 5, and 3.3 volts. We call these different voltages rails. Think of them as different pipelines serving different neighborhoods in our digital city. The most important one in modern computing is the 12-volt rail. The 12-volt rail is the heavy lifter. It powers the CPU and the graphics card, which are the two hungriest components. In a high-end gaming PC, 90% of the total power flows through this single 12-volt pipeline. Then we have the 5-volt and 3.3-volt rails. These are the legacy pipelines. They power your SSDs, your hard drives, your USB ports, and the tiny logic chips on the motherboard. While they carry less power, they are still vital for system stability. But here is where the quality of a PSU is truly tested. Ripple. In a perfect world, DC power would be a perfectly flat line. But in reality, converting AC to DC always leaves a little bit of the original wave behind. This residual waviness is called ripple. If you have a cheap power supply, the ripple is high. The voltage fluctuates wildly, acting like dirty fuel in a high-performance engine. This causes your PC to crash randomly or freezes your mouse, and you will never know why. A high-quality PSU uses massive capacitors, those cylinder-shaped batteries you see inside, to smooth out this ripple. Japanese capacitors are the gold standard here because they can withstand higher temperatures and last for decades without leaking. Now, let's talk about wattage. This is the number everyone looks at. 500 watts, 850 watts, 1000 watts. But how much do you actually need? The answer lies in the concept of the efficiency curve. Power supplies are not equally efficient at all loads. They are usually most efficient when they are running at about 50% capacity. If you run a PSU at 100% load constantly, it gets hot, the fan spins loudly, and its lifespan drops. Therefore, you should always buy a PSU with headroom. If your PC parts consume 500 watts, Do not buy a 500-watt unit. Buy a 750 or 850-watt unit. This keeps the unit quiet, cool, and ready for future upgrades. This brings us to the 80+ sticker you see on the box. 80+ white, bronze, gold, platinum, and titanium. Many people think a gold PSU provides better quality power than a bronze one. That is a common myth. The 80+ rating measures only one thing: power efficiency. It tells you how much electricity is wasted as heat during the conversion process. An 80+ gold unit wastes less electricity than a bronze unit, saving you money on your monthly electric bill. However, high efficiency usually correlates with high quality. To achieve platinum or titanium efficiency, engineers must use premium components. So while the sticker only measures efficiency, it is often a good proxy for overall build quality. Safety is another critical feature invisible to the naked eye. A good PSU has a team of bodyguards built into the silicon. We call these OVP, over voltage protection, OCP, over current protection, and OTP, over temperature protection. Imagine a lightning strike hits your house, or a short circuit happens on your motherboard. A good PSU detects the surge in a microsecond and sacrifices itself, shutting down instantly to save your expensive CPU and GPU. A cheap PSU? It just lets the surge pass through and fries everything you own. Let's discuss the cables, specifically modularity. In the old days, power supplies looked like an octopus. A giant bundle of every possible cable was permanently attached to the box. You had to hide the unused cables inside your case, blocking airflow. Today, we have modular power supplies. The box has empty sockets and you only plug in the specific cables you need. This makes building easier and the inside of your computer much cleaner and prettier. But I must issue a massive critical warning here. If you have multiple modular power supplies, never mix the cables. The plug that goes into the PSU side is not standardized. A cable from a Corsair PSU might fit into an EVGA PSU, but the electrical wiring inside might be swapped. If you use the wrong cable, you will send 12 volts directly into a storage drive that expects 5 volts. You will see smoke, you will smell burning plastic, and your drive will be dead instantly. Modern GPUs have introduced a new challenge: transient spikes. Powerful graphics cards can sometimes demand double their rated power for a fraction of a second. Older PSUs would see this as a short circuit and shut down. This led to the new ATX 3.0 standard. These modern PSUs are designed to handle these massive power spikes without flinching. They also come with the new 12 VHPWR cable, a single tiny connector that can deliver 600 watts to a graphics card. This replaced the messy look of having 3 or 4 separate cables plugging into your GPU. However, because so much power flows through such a tiny plug, you must ensure it is seated perfectly. A loose connection here can literally melt the plastic. Another sign of a premium PSU is the fan. Many high-end units have a 0 RPM mode. If you are just browsing the web or writing a document, the fan doesn't spin at all. The unit is completely silent, cooled only by its massive internal heat sinks. So how do you choose the right one? Do not just trust the brand name. Even the best brands sell budget models that are mediocre. You need to look at independent reviews or the community-maintained PSU tier list. Always aim for Tier A or Tier B units for a gaming PC. Look for a long warranty. If a company offers a 10-year or 12-year warranty, it means they are confident that their capacitors will not fail for a decade. There is one final safety rule that you must respect. Never, ever open the metal casing of a power supply. Even if it is unplugged, The massive capacitors inside can hold a lethal charge for days or weeks. There are no user-serviceable parts inside. If you touch the wrong component, it can stop your heart. Treat the black box with the respect it deserves. It is a miniature power plant sitting on your desk. We have now successfully powered our machine. The electricity is flowing, the lights are on, and the fans are spinning. But wait, electricity creates a byproduct: heat. The CPU and GPU are now generating massive amounts of thermal energy. If we don't move this heat away immediately, the system will suffocate and shut down. We need to master the laws of thermodynamics. In the next video, we will explore cooling. We will look at the battle between air cooling and water cooling, and explain why your computer gets hot in the first place.
Don't let your system overheat. Tell me in the comments, have you ever had a power supply explode on you? If you found this explanation helpful, please hit the like button and subscribe to Computer Lessons. Don't forget to click the bell icon so you don't miss our next class. Thanks for watching and keep learning.